Alright, hell yeah. So we're going to do a little matrix algebra, and we use Gaussian elimination to take three equations and get it down to where we can solve for one of the values. So if you're not familiar with matrices, this is going to represent three equations. We're going to have 1x plus 5y minus 3z is negative 9. The next equation is going to be 0x minus 13y plus 5z is equal to 37, and so forth. And maybe this came from, three equations that looked like this. You have 1x minus 3y is plus 5z is equal to negative 9. And so Gaussian elimination allows you to take one of the equations, like let's say this one, and make this 3x minus 9y plus 15z times negative 27. I'm just multiplying this equation by 3, and then I have two equations that have a 3x and a 3x, and I can subtract those equations. I can do the same thing with this one, and what we can do is we can eliminate this variable, and this just becomes 0. And then I can do that process on repeat, where I get this value to be 0, this value to be 0, and then I have two equations that I can get the y values to be the same and subtract them, and I can get this value to be 0. That's how we get down to an equation where we have just something here in the z term is equal to a constant, and then a y term and a z term is equal to a constant, and then the original equation, the x term, the y term, and the z term is equal to a constant. And if you do that Gaussian elimination, where you can get this echelon of zeros, you're pretty much there. You're just trying to get this to be zeros, and what that does is it allows you to have a solution for so right here, I have a solution for my z value, kind of. This says 5z is equal to negative 15. A very simple equation. 5 times what is equal to negative 15. Let's forget about the negative. 5 times what is equal to 15? 5 times 3. So z is going to be 5 times negative 3 is 15. And once I know my z value, I'm going to come up here and say 5 times negative 3 plus 13 times y. I don't know y, but that's going to equal 37. So it's pretty simple to just take 37 minus, I'm going to take 37 minus 15 times negative 3. There's a couple negatives in there. So basically going to take 37 plus 15 and take that and then divide by this negative 13. So sweet. So I'm going to have 37 plus 15. That's going to be 47 plus 5 is 52. 52 divided by 13, I'd imagine that works out because 13 goes into 26 and 26 doubles to 52. So hell yeah. So it looks like my y value is going to be negative 4. And so again, we're just kind of doing this using mental math, and let's check out what they get. So what we want to do is to get it into a form like this. And all this says is like, hey, this z value is negative 3. The y value is negative 4. So let's just kind of see how we do that from here. What did we do to solve for z? Well, we essentially just guessed. We said 5 times what is negative 15, and that's negative 3. The other way to do that is just divide both sides of this equation by 5. And then I'm going to have z is equal to negative 15 divided by 5. Negative 15 divided by 5 is negative 3. So I'm going to have a 1 right here. That's going to represent this z term. So 1 is equal to negative 3. Now we can do the same thing up here. I want to get this term to be 0, and I want to get this term to be 1. And so I do that by taking 37 minus 5z to the other side, and z is a negative 3, so minus a 5z is going to be just adding 15 over here. So I'm going to have 52, and then I'm going to divide by 13. that makes this value a 1. So now I have 1, 0, and then I'm going to have 52 divided by negative 13. That gives me a negative 4. And so now my new, what this looks like is 0, 1, 0, negative 4. And then this row is 0, 0, 1, negative 3. And then you read that as this y term is equal to negative 4, and the z term is equal to negative 3. But right here is the first place, if you're using the matrix method of trying to get zeros into this corner, an echelon of zeros, using the Gaussian elimination, once you get down to here, you know your z value, therefore you can kind of know your y value. And if you know both those, hell yeah, you know your x value pretty seamlessly. But if you go this extra step and turn this into a 1, this into a 0, this into a 1, and then the final thing to do is turn this into a 0, this into a 0, and then this into a 1. This is already 1, so we won't have to divide by anything, but we do need to get these two terms to the other side. So I'm going to have negative 9 minus this term, which is a negative 3 times z. Z is a negative 3, so let's say that. Negative 9 minus negative 3 times negative 3. Well, let's just do the negative 3's together, so that's going to be 3 times 3. That's going to be a positive 3 times 3. So I'm going to have negative 9 minus, 3 times 3. So negative 9 minus 9 is going to be negative 18. Cool. Let's do this next one. So I'm going to have negative 18 minus 5y. Y is negative 4. And so it looks like I'm going to add that. So I'm going to have negative 18 plus 5 times 4 is 20. So this is going to be negative 18 plus 20. It's going to give me a positive 2. And so it's going to be 1, 0, 0, positive 2. And so my x value is going to be 2. And I swear, like what we just did mentally is, I think, the prerequisite for doing matrix algebra. Like that's what I've been learning, is it's very useful to be able to juggle addition and multiplication without having to grab your calculator. Just because this process gets messy, and you want to be able to do those fairly simply. Cool. So, and that's kind of the video, you know what I mean? Like obviously in this, what they do in this is totally different than what I just did. I mean, they see that we have a 5 and a 5 here. I mean, well, the first thing they do is just divide this by this row by 5 on both sides. Then you get a 1 here and a negative 3 there. Cool. But now that I have I want to get this value as 0. So I'm going to go back to boosting this up to 5 because that matches this. If this is 5 and this is 5, I can cancel these two equations or subtract this equation. And I don't know how you say it, but you take this equation and subtract that equation. That gets rid of this value. And so if I multiply this by 5, this goes back up to negative 15. And if I take this, subtract this, I'm going to have 5 minus 5, this is 0. Negative 13 minus 0, this stays negative 13. And then I'm going to have 37 minus this negative 15. So that's where we get that addition of 52. So that's what we do down here. And now I'm going to have negative 13, 0, 52. I still really want to get this 1, so we just do the common thing of just dividing both sides by a parameter, and that's going to be this negative 13. So that's what we do in this step, and we get this to be a 1, this to be a negative 4. And it looks like they already got this to be a 0. What did they do there? Let's see what they did. Well, they said, hey, let's do the same thing. Let's boost this equation up to 3 or negative 3. It looks like they just boost this equation up to 3. You can either get this, you could multiply this equation by a negative 3 on both sides and then subtract the equations, but it's also good to get used to, If we multiply this by 3, I'm going to have a 3 right here and a negative 3, and then I can add these two equations. So that's what they're doing here. They're going to add the top equation, which is negative 3, and then we're going to add this bottom equation that we multiplied all of it by 3. So this value is going to be negative 3 plus 3, so we get a 0 there. This term is going to be negative 9 plus this multiplied by 3. So it's going to be negative 9 plus a negative 9. And that's what we have here. That's where we get this negative 18. Cool. So we got a 0 there. And then the final 0 is to get make this a 0. And what are they going to do? Yeah, that makes sense, because you have to get these two to be the same, but first let's get this to be a 1. So we're going to take this line and divide both sides by negative 13. So that's how we get this value to be 1. And this value to be negative 4. And now we can go through the process of boosting this up to 5. So I can take this equation and say this is 5 in the y spot. And then this is going to multiply both sides by 5. So this is going to be negative 20. So I'm going to have 5 and negative 20. Then I need to subtract the equations. I could have multiplied this equation right here by a negative 5. That might be, that for me, I enjoy doing that because I can just say, hey, I'm going to put a negative 5 here. I know these are going to cancel when I add them. And then I'm just going to turn this into a positive 20. And it's easier for me to say, what's 20 plus negative 18? Just because I can do it, the order doesn't matter, even though I don't know, does order, see, I get confused. Does order matter when you just do subtraction and addition? Probably not. That's something that I'm learning, and this is a freebie on me, or just, you know what I mean. I finally looked up what commutative means and associative, those two properties. Commutative means that you can add 1 plus 1, or you can add 2 plus 1. You can do those in either order. And check this out. If you're commuting to work, you can go from home to work, and then you can commute back, go from work to home. I'm sure someone's come up with that axiom. I don't make short videos that make millions of views, but I think that is a little piece of gold. And if I get on the ball, hell yeah, I need to make a little short video just of that parameter. You know what I mean? Commutative property, I'll never forget it now. You know what I mean? Can I take negative 1 and subtract? Well, damn it, I don't want to get into the addition because I think I'm going to run into a hiccup. If I think there is, isn't subtraction not commutative? That's a question for you. You know what I mean? If you put what's being subtracted, I don't know. If you have the right amount of parentheses, I think it works. And if you add, but anyway, that's why I like adding negative numbers, because you can use the commutative property. I can be negative 18 plus 20, or I can be 20 plus negative 18. But subtraction, I don't know. It doesn't sound commutative. It doesn't seem like I can commute one way, home to work, and work to home the other way. Associative just means groups that you're associating. So those are the parentheses you're going to be putting around things. If I'm adding 1 plus 2 plus 3, I'm going to put parentheses around the 1 and the 2, and then add those first, and then add the 3. And addition is associative. I can group any way that I want. I can put parentheses around the 2 and 3, do those first, and then add the 1. All right, hell yeah, that was a worthwhile side note for me, because I'll get better at making that little video. So hell yeah, we want to get this value to be 0. So we're going to boost this up, like I said, to a negative 5. This becomes positive 20. We're going to add those, and we're going to get a 2 right here. Positive 20 plus negative 18 is 2. This value goes away. So we're going to have 1, 0, 0, 2. And now we have our solution set. Our x value is going to be 2. Our y value is going to be negative 4. And our z value is going to be negative 3. Hell yeah. If you got this far, might as well leave a like. And I'll heart your comment. Booyah.